Hello, everyone. Welcome to our last webinar session of the day. I am just getting myself situated since for some reason it always looks a little funky to me when I am screen sharing, which is super duper fun. Okay. To all my attendees, can everyone see my screen normally? Thumbs up if you can. Just want to make sure everyone's seeing everything perfect. Okay. Well, welcome everyone to our final session of the day. This is going to be a pre-recorded session with Dr. Goodarzi and Dr. Alison Wallace. Dr. Wallace was unable to join us today in person, but we were lucky enough to have Dr. Goodarzi join us for our Q&A afterwards. Let me get to my notes. So Dr. Alison Wallace, she is a thoracic surgeon and scientist with 2 patents and 26 peer-reviewed publications. Her clinical practice involves the surgical management of benign and malignant diseases of the lung, pleura, mediastinum, and esophagus using minimally invasive robotic techniques. And her research focus is on better understanding the molecular mechanisms of environmental exposure related to lung disease and lung cancer. Her interest in lung disease propelled her to pursue a career as a thoracic surgeon, and she is compiling a repository of lung tissue samples and developing organoid models to better understand the mechanisms by which environmental exposures promote the development of lung disease like cancer and COPD. She is part of the EVICT Radon National Study and the Canadian Environmental Exposures to Cancer CE2C network, which encompasses national, multi-university-based transdisciplinary teams working to understand the etiology of environmental carcinogen-based lung-induced cancers in Canadians. And she is a thoracic surgeon here at the QE2 here in Nova Scotia. So we are super lucky to have her here in Nova Scotia. And Dr. Goodarzi is a biologist expanding our understanding of how ionizing radiation impacts our DNA to cause disease, including cancer, and is based at the University of Calgary. His team is working towards understanding the scale and causes of the Canadian radon problem, finding the genetic signature of radon-induced lung cancer, and determining amongst us who may be especially susceptible to cancer after radon exposure. And he is also the board chair of EVICT Radon, and I'll let him introduce himself a little bit later on, and I'll get started with our presentation.
National Study, which is a Canadian national research project aimed at understanding and engineering out radon exposure as a source of lung cancer. Our work is supported nationally by Health Canada, CIHR, and the Canadian Cancer Society, and really involves a large...
Love when the sound doesn't totally work. Check sound.
Interdisciplinary group of university-based public researchers from across the nation, coast to coast, who span multiple disciplines, biology, medicine, psychology, architecture, building science, communications, you name it. We're working together as we tackle this problem. And so I'm speaking to you. My name is Dr. Goodarzi, speaking to you from the University of Calgary School of Medicine in the Prairies. And I will be joined shortly by Dr. Alison Wallace from the Division of Thoracic Surgery at Dalhousie University in Atlantic, Canada. Say hi, Alison.
Hello, everyone. Thank you for the opportunity to participate in this important workshop.
Thanks, Alison. And so what we're really focused in on is the Canadian lung cancer crisis. And this figure is taken from the Canadian Cancer Society 2020 report, which concluded, and you can see here based on how red Canada is, that regrettably we have amongst the highest lung cancer incidence and mortality rates in the world. And why is that? I want to pose a provocative question. So we have this map where Canada has exceptionally high incidence and mortality from lung cancer, but I'm going to contrast that to this map, which is the share of people who smoke every day. And in fact, one of these things is not like the other. Canadians, in fact, do not smoke much, and that has been remarkably successful in terms of tobacco cessation over time. If we compare two cold climate countries, here's where my provocative question comes in. Canada and Sweden, both in the north, highly developed, educated, generally healthy populations with, in fact, identical tobacco use rates today, having come down at similar rates over time. Yet if you compare the rates of lung cancer between those, they are dramatically different. What does this provocative question tell us? Well, it tells us that there are many other sources of lung cancer than tobacco. And in fact, in Canada today, lung cancer arises in individuals who have never used tobacco about 20% of the time. So 1 in 5 people who eventually are diagnosed with lung cancer have never used tobacco. And so what are these non-tobacco lung cancer causes? There are many. Air pollution being a big one, forest fire smoke, perhaps things from industry, things like asbestos, which thankfully we've largely removed from a lot of the built environment, at least it's not being installed freshly. Arsenic, which is very prevalent, for example, in Atlantic Canada. And of course, the big one, which we're here to talk about today, which is radioactive radon gas. So let's focus in on that, because amongst these, it is thought that radon is the leading cause of lung cancer and in people who do not smoke. And as part of the Evict Radon study over the past 5-6 years, we have been systematically analyzing radon exposure in Canadian residential households. And so this big sort of graph here, every single one of these dots you're seeing is one Canadian house, houses all the way across the country, every province, every territory. And what we have found overall is that about 1 in 5 Canadian houses contains radon levels in excess of 200 becquerels, and more than half contain radon exceeding 100 becquerels per cubic meter, which is where you start to see an increased risk of lung cancer. Compared across the world, unfortunately, Canada is one of the most radon exposed countries on this planet, with the prairies, the North and Atlantic Canada occupying the 2nd, 3rd, and 4th most radon exposed populations globally, with Central Canada at number 7 and Pacific Canada at number 16, still very, very high in the top 20 there for exposure. If you look across the nation, again, it's about 1 in 5, no matter where you look, properties exceed 200 becquerels per cubic meter, with averages in Atlantic Canada and Prairie Canada and Northern Canada being about 100 becquerel per cubic meter in properties. And so this comes back to my provocative question of what's the difference between Canada and Sweden over time. As I mentioned, one country, us, we have much higher lung cancer rates. And in fact, there are 163% greater incidence and mortality from lung cancer here in Canada versus Sweden, on the background of both countries having about 12% tobacco smoking rates. The difference, and we published this late last year, is in fact radon. And where originally in the middle of the 20th century, Sweden, in fact, new houses there had higher radon than Canada. By the 1980s, they were the same. Today, a new Canadian house has 467% greater innate risk of radon compared to a new Swedish house. And so the huge difference we've seen over time has not become tobacco, and in fact is non-tobacco sources of lung cancer, such as radon gas. This underlies the interdisciplinary work that the Evict Radon study is doing. You can find all of our publications for free download at our website. But what we're gonna transition to is how can we use this knowledge to make an impact for Canadians? How can we translate that knowledge to action? And with that, I'm going to give over to my colleague, Dr. Wallace, who will take us through the next steps.
Thank you, Dr. Goodarzi. One thing that we have been focused on is figuring out better ways to prevent, or at least address, the devastating impact that lung cancer can have on individuals and populations. One of the biggest problems that we have today is that lung cancer is diagnosed at late incurable stages, both in males and females. You can see from the pie charts here, close to 50% of both males and females are diagnosed at stage 4, and another 1/5 are diagnosed at stage 3. Well, what does this mean? Lung cancer, like all other solid organ cancers, is staged from 1 to 4. Stage 1 being early curable disease with localized treatments, whereas stage 4 is advanced disease that has spread around the body outside of the lungs. More specifically, with stage 1 disease, the cancer is small, less than 3 centimeters, and confined to your lung tissue, but has not spread to the lymph nodes or further. In stage 2, the disease is larger and may have spread into the lymph nodes or other parts of your lungs. Patients with stage 1 and 2 disease often have no symptoms. Stage 3 has spread further into the lymph nodes and invades the surrounding structures. And stage 4, the most advanced stage, has spread outside of the lungs to other parts of the body. Lung cancer typically spreads to the brain, bones, or adrenal glands. Stage 4 lung cancer is incurable and very challenging to treat. You can see survival here in this slide with the stage of lung cancer on the x-axis and percent survival on the y-axis. Long-term survival for stages 3 and 4 is less than 50%. And up until recently, survival for stage 4 lung cancer at 5 years was 0%. Survival for stages 1 and 2, where the disease has not spread around the body yet, is far better than for stages 3 and 4. So the question is, how can we improve lung cancer diagnosis and detect the disease at stage 1 or 2 when the disease is curable, as opposed to stage 3 or 4, where the outcomes are very poor? Early detection leads to better outcomes. The answer to this question is lung cancer screening. And thankfully in Canada today, lung cancer screening programs are emerging across the country. Lung cancer screening programs are based on a technology called low-dose computed tomography, or CT scans, which use low doses of radiation to visualize what's going on inside the body. And this type of imaging is particularly accurate for imaging the lung tissue. A CT scan is shown here on the right of the slide, and the arrow points to an early lung cancer growing in the lung tissue. This nodule, as we call it, has the typical spiculated or starburst pattern. If you can catch tumors at this early stage, where patients are always asymptomatic, they are curable with surgery. Specifically, the surgical procedure is called a lobectomy. The benefits of lung cancer screening have been shown in numerous studies conducted in both Europe and the United States. The pilot projects are now more than a decade old. The National Lung Screening Trial showed a 20% reduction in mortality with annual screening for eligible patients. How do you become eligible for lung cancer screening? Well, to pass go and move into the program, you have to meet this, which is you have to be able to demonstrate a 1.5% risk of lung cancer happening in the next 6 years. At this time in Canada, these are the criteria for lung cancer screening. Patients aged 55 to 74 years old who are current smokers or former smokers having quit in the last 15 years with heavy tobacco use, and that means 20 to 30 pack year smoking history, which is calculated by the number of packs of cigarettes smoked per day over the number of years smoked. This status quo really is a problem from a health equity perspective because it does exclude. As you can see in this picture here, you have two young women here. The one in the background, who theoretically is a non-tobacco user, she would not meet the eligibility criteria for this program. And in part, this is an economic equation. It's simply not feasible to screen everybody. And another part of the risk calculation is because the CT scan does carry some risk of radiation exposure, and therefore you don't want to be exposing this risk to large populations of people who do not need it. Unfortunately, there are across populations, if you consider the diversity of the human experience, large numbers of people, in fact, 40% of people who will eventually develop lung cancer will not meet current eligibility criteria because either they have never smoked tobacco or they don't smoke enough. So how do we change the way we do things in screening in order to make those folks eligible? This is really important because if you look at the difference between tobacco-associated lung cancer and non-tobacco associated lung cancer, the non-tobacco group is actually the 7th leading cause of global cancer mortality. I mean, this is a huge population of people who need inclusion within lung cancer screening programs. And in fact, in the Canadian Cancer Society report, the projected saved lives are profound if you can move people from being diagnosed overwhelmingly at stage 4 to being diagnosed at stage 1, which of course is the goal of screening. And so how do we get there? How do we enable more people who need it to access lung cancer screening? Naturally, this involves a variety of things. And so where do we start? Well, we've been doing this as part of the Pan-Canadian Coalition of research involved in the Evict Radon study and others, where we're basically doing a lot of measuring. And what are we measuring? Well, we have to measure all those non-tobacco risk factors for lung cancer. It's quite straightforward for someone to report when they started smoking, roughly how much they've smoked, and over how many years. But it's far, far different for people to report exactly how much combustion particles they've been exposed to, how much radon, how much heavy metals, how much asbestos they've been exposed to, because often these things are hidden from us or challenging to measure at the individual level. In this regard, one of the things we're working towards is biomarkers, evidence of these exposures that are retained within our bodies over the long term and as we age. And can we use these biomarker clues to work towards new eligibility criteria is the question. As a thoracic surgeon, I have the privilege to treat patients with lung cancer. I find my patients are very willing to participate in research and keen to consent for these projects. What we're doing right now in the lab in terms of biomarkers is examining the surgical specimens and specifically looking at the DNA damage both within the tumor and the healthy surrounding tissue as evidence of lifetime exposure to things that cause lung cancer. We are also looking at the lung microbiome, how changes within the lungs will go on to affect the microbes that make up our GI system. We can also look at the very nature of the cells there, the tumors versus the surrounding healthy tissue. And through discovery like this, we're hoping to get to the biomarkers that we need to confer eligibility for lung cancer screening. This is a challenging prospect, and the problems that will arise in doing this, as you might imagine, are many, but we are developing solutions. And to speak further, I'll hand back over. Thank you very much.
Thanks, Alison. And so one of the things that we've been doing as a way to identify some of these challenges and build solutions is really specifically look at the paradigm of radon exposure in large populations. Lots of us in Canada especially will be exposed to radon throughout our lives, and we will not know it for most of it. And so how do we address the fact that it is next to impossible for someone to offer up lifetime radon exposure information as an eligibility criteria? It's not realistic that most of us will have access to information from our childhoods, even our young adulthoods. We probably don't live in those houses anymore. If we even have access to them, the radon can change in properties over time. So how do we address that? You know, we can't report radon as we can tobacco usage. And so we have to move towards a better way. And so this is a large part of what the Evict Radon study has been doing over the past 3 years, is finding a better way. the holy grail, so to speak, of a so-called blood test for lifetime radon gas exposure. And we now have some technology that is helping us with that process. And this little greenish picture you're seeing here is an inductively coupled mass spectrometer, plasma mass spectrometer, I should say. And what we're doing with this technology is taking advantage of a key event that happens in human radon exposure. So perhaps you don't know this, perhaps you do, but when one inhales radon gas, it emits radiation that goes on to damage the DNA of the lungs, which drive cancer. But as it does so, that radon transforms from a gas to a solid, which very quickly emits yet more radiation, becoming solid radioactive lead-210. There are very few sources of solid radioactive lead-210 in your diet or the environment other than, in fact, radon gas. The half-life of that specific radioisotope is more than 2 decades. It will, in fact, like most lead, accumulate within our bodies over time, so that the radon you inhale in your house, you'll walk away with, and it will continue to accumulate, emit radiation. We're hoping that this can be detected. And in fact, to do that, we need to get down to an incredibly small degree of sensitivity. So if we consider the general paradigm of the metric system, you know, like a centimeter, for example, or a millimeter, you can see there, we actually need to be down in the femto range. 10 to the negative 15th exponent there, 1 quadrillionth of a unit there in terms of grams of product. Now, historically, we just simply didn't have the technology to do that. It now exists. I told you about that mass spectrometry method. And what we're doing is we're taking the participants in the National Evict Radon cohort, which involves many folks from Atlantic Canada, and asking them if they would be willing to participate in this research, because we know about long-term radon exposure for many of them. They've told us, we know their radon levels in their house, and they've told us perhaps how long they live there and how many hours a day they may spend, and asking them to donate some toenails. Why toenails? Because lead is one of the ways it's sort of excreted from the body is in things like hair and toenails. Toenails are easy to collect and store. Not many people are shy about giving those out. It's quite different to blood, for example. And by understanding the radon exposure plus people's activity patterns, you know, how much time spent at home, we can calculate doses. And so this is the essential part of what we're doing. We know for all of these participants, their long-term radon exposure. We can then go and analyze their toenails and see how much the amount of lead-210 in the toenails correlates with known exposure. So this is a sort of paradigm that we've produced for Canadian radon gas exposure doses. So the radiation doses you might get. You know, what's striking is that we've already determined that the Canadian average radiation dose from radon is 3 times the global average, with a striking number of people receiving levels much higher than the maximum tolerated exposure for a nuclear energy worker, and in some cases as high as you might get from a year spent in space. From the doses of radiation we're seeing in houses. So over the past couple of years, we've done a pilot project on 75 people split between 3 groups. The first, known high and long-term exposure. The second is our negative control, low long-term exposures. People had very, very low radon in their houses and lived there for multiple decades. And then another sort of wildcard group, those that haven't lived very long, but they have lived in houses with very, very high radon exposure. And so compare the 3 groups. And so if you're interested in the doses, that's what those look like. You know, more than 10 millisieverts a year of radiation for more than a decade represents the high, versus less than 1 millisievert for more than 10 decades is the low exposure group. We've been controlling for everything, including their tobacco use, what they do for a living. You know, for example, are they an underground miner? Do they work in a fish farm that could potentially have high radon? Things like medical radiation and sort of things you might not have thought of, which is how much moose meat they might potentially eat, because weirdly, moose meat contains high amounts of radioactive lead, or potentially can. So understanding all of that, we know we can detect it. The mass spectrometry technology is working. We can get down to the femtogram level of sensitivity for that specific isotope that causes, that is from radon exposure. And here's our preliminary data. We've analyzed a couple of dozen of the cohort so far. As we work through the rest of them, we compared just 2 groups, the high exposure group, who averaged at 340 millisieverts of total exposure. That corresponds to radon levels of about 500 or more becquerels over the long term. Compared them to folks in low radon houses, less than 20 becquerels, for again 10 to 30 years. And wonderful news, it is working. We in fact find lower amounts of radioactive lead in the folks that we know have low radon exposure, and much higher, in fact 500% higher amounts of radioactive lead in the toenails in folks that we know who have been in high radon households. So these are preliminary findings. Of course, there's a long way to go, but it shows a great deal of promise as we work towards a new technology that someone could come in, give some toenails, we say, yep, verified high radon exposure over the long term. And of course, the big challenge right now is to correlate that with lung cancer risk, which you might imagine involves a lot of mathematics. But we're working towards a larger scale clinical trial where we use this as a basis to refer people to lung cancer screening programs as they emerge. Of course, we have to deal with a lot of regulatory hurdles as we do that, and that will require time and effort and funding to make that happen. But it's really promising that the work we're doing in the Evict Radon National Study, which again involves scientists from across Canada, including Atlantic Canada, like Alison, are making this possible. And so with that, I thank you, and I'm sure Alison does as well. We'll be available for questions. And just to acknowledge all of the good folks, you can find more about our study at evictradon.org. We're funded by a variety of different groups. And
all right, I'm gonna unpin myself. Thank you so much for putting that presentation together with Dr. Wallace. We really appreciate you guys taking the time out of your schedules. Let me remove my pin and let's get to some questions that I know that we have. All right. What about occupational exposures in the screening criteria? Is there any occupational flag that's considered in the screening eligibility decisions?
Well, at this time, it's holistic radon exposure. So we really do have to also consider occupation as well as residential history. So that's why we've been asking people in the study what you do for a living. You know, what's your job? Where does it occur? And there are certainly some professions that carry a higher radon exposure risk than others. You might envisage a scenario of an individual who works as an administrative officer in a building, possibly in a basement office, versus a farmer who works outside. Different exposures, different jobs, and we are trying to understand that, yes.
Great. Not sure if this is a you question. If lead 210 is found in toenails, does that mean it's traveled through the blood vessels?
Yeah, it's everywhere in the body. Yeah, so radon dissolves as a gas very easily in blood. Most of the radon that you will absorb as it emits radiation will, of course, end up in the lungs. Well, what's the lung? It's a place where all the blood in your body goes to get oxygen. And of course, it will be carried through other tissues. And so even back as far back as the 1960s, people were detecting radioactive lead from radon with poor sensitivity, not enough for our use today. We just got that tech, but they found it in the bone of your skull, in your toenails, in your hair. That's how lead generally is excreted from the body. It's very slow, and typically 75% of all lead we absorb is retained for the long term. That's why lead is intrinsically toxic. This is not enough lead to give you lead poisoning. It's radioactive though, and that's why we can detect it in this way.
Okay, and then another one, radon being a noble gas is smaller in size than the oxygen molecules migrating from air to blood side of our lungs. Research showed fetuses can get radon, so is it through the blood for sure that this transfer happens?
Yeah. Okay. So as I say, there's a proportion of radon that you'll inhale that will dissolve in the blood, and that can be carried anywhere that the blood goes to. So that would theoretically include a fetus, although we have to reflect on the fact that the proportion that is going to hit the lungs is going to be many, many, many orders of magnitude greater than whatever hits everywhere else in your body. Yeah, we can detect it elsewhere, but femtograms, I mean, 10 to the negative 15, it's not much. So far, it would be, the biology would not support that radon that you inhale as a mother impacting your fetus. It just wouldn't be enough radon to get there unless it was something that you typically would never see in the environment.
Okay, and then a correlative question to that is, can I'm going to butcher this, I apologize. Polonium decay trigger other cells in the whole anatomy at random, induce other illnesses and conditions?
No, not, sorry, phone call going off, closing the door. No, the only real disease associated with radon and its decay product is lung cancer. There is, of course, a variety of diseases associated with radiation exposure, but in this case, it's alpha radiation exposure. Doesn't travel far, and overwhelmingly will only hit the cells lining our lungs. That's an epithelial cell, and that's what drives forward towards lung cancer. No other diseases have yet been supported by the medical literature to be caused by radon exposure.
Great, amazing. Thank you so much for taking the time and joining us. And have a great day. Thank you for coming extra early since you're 3 hours away, different time zone. Everyone, this is our final webinar session. We're going to move to our roundtable, so I'm super excited for that, to see everyone's face and to have a great open discussion. I will see you guys momentarily. Have a good one. Thank you.